Hello, everyone. We're here just to kind of give you a review on Goal 1 for the thermal energy unit.
Okay, we're going to start off by talking about what happens to a substance when you add thermal energy. So here we have our PET simulation where you can slide the bar and start to add heat energy to your substance. And as you can see, as we're adding that heat energy, we can start to see that those particles are moving further apart. And not only that, but they're also moving faster. So that means that our kinetic energy or our particle motion is increasing. So as we add heat energy, we're seeing that the particles are moving faster. And so if you look at our chart here on the side, we can see that as thermal energy is gained, that heat is increasing, the temperature is increasing, particle motion is increasing, the space between the particles is increasing. So all of these showing that there's a direct relationship between adding heat energy to your substance and causing the particles to move faster, further apart, and to transition. So if we were to keep adding heat energy, well, let's see what happens to these particles. Notice that they start to bounce around and bump into each other a lot more. We can see that they're taking up all the space of that container and really kicking up their motion.
So at this point, it's converted entirely to a gas substance as well. So we started with a solid, and when energy was added, it turned into a liquid, and now it's reached a full gas state as well.
Now we're going to slow things down. So in order to do that, we need to take away heat energy. We need to take away that thermal energy. So we have to drop that temperature. So we're going to cool things down by sliding the bar down.
If you watch the thermometer in the corner, if you can see it, the number is getting lower. So this is a unit in Kelvin right now, which is basically a temperature unit, but the value is getting smaller, representing that as you're taking away heat energy, the temperature is decreasing as well.
And take a look at our particles now. As that temperature is decreasing, we can definitely see a change in the motion of those particles. They're slowing down, they're coming closer together. So the space between your particles is decreasing, the particle motion is decreasing, and they're coming closer and closer and closer together. Check that out. So what this shows us is that there is a direct relationship, once again, to our thermal energy. And as our thermal energy is decreasing, our heat is decreasing, the temperature is decreasing, particle motion decreased, things got slower, and the space between the particles got a lot smaller. They got much closer together.
And once again, it started off as a gas. Then as we slowed the particles down, they moved closer together and it became a liquid. And now you can see that it's kind of back in its solid state where the particles are just vibrating very close together, very little particle spacing between them.
So there you have it. That's goal number 1 in our thermal energy unit.